yeah, so for the past like couple of years, I wanted to learn C++. I have it's like at the top of the list, but I keep getting distracted and never learn it. So for the next couple of for the next couple of Sundays, sorry, Saturday streams, I'm gonna be learning C++. So that's kind of how it's gonna work. So like Mondays, I'm gonna spend some time like making our streaming tools better, and then on um, Thursday, we're gonna do like some SRE DevOps kind of thing, and then on Saturdays, I'm gonna try to learn something new. Um, so today, and that something new will be like it could go on for like months. So today we're gonna start just like learning the basics of C++, and then we are gonna start building a Lisp interpreter. So the goal is that after a few like weeks, maybe months, we are gonna start taking. So I created a Lisp interpreter a while back in Go. So we're gonna be working on turning that. Oops, not this. Lisp. We're gonna try to turn this into a C++ project. That will be like the end goal. The end goal is to go from like just from pretty much not knowing anything about the language to going and building a interpreter out of it. Maybe even the last step is building a binary. But the way it will work is that we kind of need to learn the whole language, most of the language at least, before we start doing some of these things. And the reason why we're going to do this project is because it's going to teach me how to manipulate strings. It's going to tell me mostly like how the language itself works. So just learning the foundation of the language. And then after that, we might try doing some other different projects in C++, like a T-Tac-Dog game or something like that. But for now, we are just going to learn the foundations, the basics of the language. I might skip some things since I might already know them. But that's kind of how it's going to go. So it's mostly to learn the basics of it. I want to know how the language itself works, how do you declare variables, and like how to create strings and things like that. So yeah, that's kind of what we're going to be doing today. And so the stream's supposed to start Saturdays at 10 a.m. But we started a bit late just because like I had a bit of struggle to getting things set up correctly. For some reason, all my OBS just reset it completely. Cool. So the first thing that I think I need is a compiler. So I was thinking of using, I believe this is, yeah. So I want to use Clang. I think that's the name of it. So I want to use this one because it uses LLVM. So I want to start using LLVM for some of the stuff we're going to be using in the future. For now, I just want to use it and see how it goes. So I just need to learn how to install it for a Mac. Yeah, so the first thing I'm going to do is just install it, install a compiler. I think I could probably use homebrew for it. Yeah. Okay, so I could just use homebrew. So that will be like the first thing. The first thing that we need is a compiler. So I chose I chose Clang just because it uses LLVM. I want to use it for something else in the future. So I just wanted to just have it there so I could learn how to like have it to be able to use it. And from there, we could start just like writing some simple programs to learn the language more. So I'm going to be using C++ 17, which is kind of like the newest standard. When it was finalized, but I don't think most compilers are using it yet. So I just want to use some of the things. I want to start using some of this 17 first, and then learn some of the new features of 20 afterwards. I was thinking of learning 11, but a friend suggested that I should learn 17, which is better. And then I found this learncplus.com, which has, I believe is the creator keeps updating it with the new changes from each like each language standard. Every time the standard gets updated, they go and update it here. So it has like a lot of information that we could be using. So it's very cool that he keeps updating. So I won't be doing the tests themselves. I'm just gonna go and like do like the sample programs that he's doing or they're doing. Yeah, still downloading. Okay, so while that's waiting, let's pick the first chapter that we're gonna be doing. So I already picked the standard, which is 17. So I just need to learn how to do that in. So I'm not sure how to pronounce it. I think it's clam, like clam. So maybe the first thing I should do is learn how to pronounce it. But for now, I'm not gonna clam, and I want to use 17. So the goal will be to just start using the latest version and like see if there's a way for us to force it to use it. Okay, so I just need to pass this flag here. So if I pass this flag here, I'm able to start using it, and then I'm able to start using some of the language changes. So I think I have 17 already. So I should have, version 5. So version 5 has all the necessary features for 2017 for the standard. Okay, so it's doing some cleanup. So homebrew is doing some cleanup, so I'm just gonna wait that it's done, and then I could try it out and see if it's there. And then I'm just gonna try like see if there's like a simple hello world that I could write. I'm still gonna be using my regular editor. We might need to make some changes to it in the future, but for now I'm just gonna just continue using my regular editor. Okay, so this is the first program. They're also using Windows, so I'm gonna be using Mac, so I might be just like jumping around a bit. Okay, so the first program we're gonna make is a hello world. And the way I like learning a new language is just like trying out, like going through the samples and figuring out what each line does. So I'm gonna do that too. So I believe I just need to do hello, that's plus. Okay, so the first is include, and then ios. Okay, and then so I also don't. So one thing I try to do is like I'm not trying to write idiomatic C++, or I'm not worried about the style of the code itself. I just wanted to get a tool. I want to understand it, so I'm gonna spend more time just going through it and figuring out like what each line is doing versus like trying to get it perfectly aligned. So, for example, I don't know what these arrows do. I could make an assumption, but I want to make sure that I kind of understand what every line does. So, okay. Cool. So I think this is our first program. So let's see if I have this. I hope. Okay. And then I want to pass this flag here. So I want to do, I'm saying that the standard library is one single dash. And then I want to say equals C. 17. And let's see. Okay, so for some reason that didn't work. So let's see what I'm doing wrong. I'm also going to look at the compiler's guide, see if there's any I want to just look at the basic usage. So It's interesting that this person is using CC. Oh, okay. I think I know the issue. So it looks like this is the C. There is C++ and there is C. So I think this is a C one. So I might have to do this one. Okay. So the issue that I was having is. Okay, cool. Yeah, that was what I was gonna say. Okay, cool. Yeah. So it looks like I was using the wrong binary. The one I was using before is the one from just regular C, and then the one from the one that ends with plus is the one for C++. Cool. So our program works. So the way what we ended up with was we ended up with a. So we have our code here. We have our hello world .cpp, and then we have our kind of our binary that we got out of the compiler. So if I do a.out, it just works. Cool. So let's go back to code. Okay. So I'm gonna write some comments. So first thing first, how do you write comments? So again, I'm gonna jump around between the different chapters, and then it's just gonna go back and forth. Okay, cool. So first, I think include. So I'm gonna make some assumptions, and then we'll go back and find the answers for it. So I think includes just it's like so in Go you have import. So I believe it's the same way. So import. And I believe iostream is a standard library. So we are importing the standard library. So this is just importing our dependency. And here is the part that is a bit confusing. So I need to figure out what this library is. Maybe I should just put it on top. Thank you for the help, Pan. Yeah, so the reason why I got there so fast was like you have the same issue with. So I didn't know if Clang has the same issue as the GCC. So if you use GCC as a compiler, there is GCC and then there is GCC ++. Okay, so here, and that's like if you do like anything with the kernel, you have to use. I was using GCC for it. Okay. So here we have, so I need to figure out what that is, and then I need to figure out what these arrows are. And then this part is easy. It's just like you create the string, and that string is being passed somehow to this one here. Oops, this one here. So whatever is doing that, we need to figure out. And then here, this is the easiest part. It's just like returning exit. So I believe this part here is just returning the exit code that is returned. So we could try it out. So if we run our application and then we do $, we get 0. So I believe that is controlled by that return variable. Sorry, by that return that we're doing there. So if I compile it again and I run it again, I should get. Yeah, I should get 1. So that controls the exit cases. So in Unix, 0 means successful and 1 means that the program itself failed. So that's kind of how failures are managed in the language. Cool. So I need to figure out what this one does. So, okay. So again, I'm making some assumptions. I'm gonna go back and fix it. So the assumption, the goal here is to build I'm building a mind map of. A mental map of how the language itself is structuring things and like how different functions are being used. This is kind of how I go about learning new languages. It's just like building a mental map and compare it to a different language. So I'm gonna be comparing it to Go because that's the language I've been using for the past couple of months. So I'm gonna go back and forth between like, oh, okay, so this is how Go does it and this is how C++ does it. I probably wouldn't go into details of like which one is doing the best because I don't know C++. So I would just keep those comments to myself. Because like at the end, it's just gonna affect how I learn the language. Okay, so I believe this. I'm not sure what to call it, so I'm gonna call it for now variable. Okay, so I am assuming that that variable there is being used to. It's like a stream, yeah. So since I'm using iostream, I'm assuming that it's a stream is a way to write to the terminal because it's a stream. So I'm streaming data to it. And then here, okay, so it's a stream. So in Go, there is the arrow operation. So you could send data to a channel. So I am assuming that we are using these arrows to send data to the stream. Okay. And I think the one for the comments is the one we were learning. So, nope. Okay, so we just need to go and find where some of these things that we're doing are being explained. So again, this person is using Windows. So some of the things that they're doing doesn't affect us or me because I'm using a Mac. I'm also not using Visual Studios either. So I'm just gonna sometimes like just skim through it and see if there's anything helpful. And they go, this is the way that we're starting. So like I'm just going through it and just like trying to figure out like most of it, like the structure of how people structure things and things like that. So and then like the way it will work is that after a certain point, I'm just gonna end up buying a book or finding another source where I'm able to learn like the basics of the like the what idiomatic C++ looks like, or what is the structure of the projects, and all these different things. Because again, I don't want to get battled down by learning the like how to write idiomatic C from the get-go, because I would spend more time just trying to figure out how to do it. Okay, so this person doesn't explain it. So maybe this one though. So I understand what a function and a statement is. So this is a function here, and I believe this is a statement. Ooh, let's double check. Yeah, so pretty much a function is just a set of statements. Cool. Okay, so he goes into more details here. So so line 1 is it is just an import. So we are importing iostream from the standard library, and it allows to, so it lets us read and write to text from or to the console. So I guess we're going to be using this a lot. So to get data from the user or to sending data to the user back into their console. Okay, so blank line. Okay, so most programming languages have a function called main as the main function, because that's how you're telling the compiler that this is the main function that is going to be called when the when you run the program. So Go, so Go, and so we have Go who has it, Java has it, and pretty much C has it as well. So that's kind of the goal there. So it's just telling the compiler like, hey, when someone runs this, you should be able to run it. You should run this. This is this entry point for this, or this is what starts the program. Okay, cool. Then line 4 to 7, it's just like the content of the function itself, and then the curly brackets just say like everything in here from here to here is part of this function. And it could be the scope too. One thing to mention is like, since I have a bit of a background with programming, I'm just gonna skim through these things, or like I'm gonna try to emphasize it again, see if I'm understanding it correctly, in case there's any weird gotchas that the language itself has. So okay, so the first statement, sorry, line 5 is the first statement within the function, and the first statement that will execute when we run our program. Okay, so this is a part that I wasn't sure what it did. Okay, so this stands for character output. Cool. Okay, so the arrows are called operator, so that's kind of the thing. So this is an operator. Does it have a name for? Okay, it doesn't really. I'm not sure what it didn't give it an like what is called. The character output. So I'm just gonna call it character. So it's an operator, and this is just stands for this character output. Okay, so the character output is used to write to the terminal as a string, and then we're using it in an operator to send data to the string. So we're pretty much just saying like, hey, here's a string, send it to our character output, and then the character output, and then the character output will be handling all the work there. Okay, so cool. And then line 6, which is the return 0, 1 is okay, yeah. So when the program finishes running, we need to send back a variable, a variable saying, hey, this was successful or not. So this is pretty much what this is emphasizing here. And again, 0 is successful and 1 is not, but there is a range of exit code that you could have in your program. So each one could mean different things, and there is like a range. There is like a range of different like codes. After a certain period, you're able to like define your own, and then like anyone that depends on your program could start listening for those different for the different ranges. So I'm not sure how Windows works when they exit code, so that might be something I should write down to learn later on. Oh, I just noticed that the overlays themselves are not working. Okay, cool. So overlays are up. So I didn't have my overlay server running. Okay, cool. So that's kind of how it will look like. So yeah, so we have different exit codes. We have from 1 to all the way to from 0 all the way to 255, and exit codes could be, yeah. So this is what I've been using to get exit codes. If you get a 1, it's an error, and that's pretty much how the people check if there is an error or not when you run the script. If you get a 0, it was successful, and then you exit a 0. But the default one always is 0, and then it's up to the engineer to decide if they want to return an error or not. Okay, cool. So again, this works is very helpful. I struggled a bit to find a place that had like the newest standard plus like a guide to how to get started. So this is doing really good so far. Okay, cool. So we could learn about syntax error. So I want to see how those looked. Okay, so we're gonna compile it. I took off the semicolon. Yeah, I took off the semicolon, and now we're getting an error. This is really good. The error itself is very specific, so we know that there is a missing, something is missing, and it telling knows where it's missing. So that's great. Sometimes there will be errors, and we would not know how to figure those out. So like we wouldn't know, like it wouldn't be easy to figure out, like, oh, okay, so I'm missing something there. So we will see those too. But it's nice to see that the compiler itself is being helpful and saying what is missing. Okay, so I'm not doing the quests themselves. I am gonna skip over those, and then we looked at comments. So comments themselves are like Go. So at the beginning, I was trying to figure out like what kind of commenting system it used. So it's pretty much like Go in C++, in C. So we have the regular ones, which are double slashes, and then we have the ones with this is a slash and a star, and we can just write something here. So I'm gonna write today's date so I know I could keep track of when we did. So there is, oh wait, I do have a date there. Okay. Cool. So it would be also useful to have the command that I used to run it. So if I come back into the future, at some point in the future, I know how to run this. We might end up learning like how to use a build system. So like I think there is like CMake or some things like that. But for now, I'm just gonna stick with just running the commands myself. Okay, cool. So we have a hello world. I should fix it. Oh, it's fixed. Let's see if it fails. Okay, so we're gonna build it. And I'm using the wrong one. Okay, and then we run it. Okay, that works. So I want to make sure that I copied it right. Yeah, I did. Okay, so cool. And if you're joining us, we just so I'm using Clang to C++ to compile our C++ package, and I'm telling it that I want to use a standard library from C++ 17, and then that's kind of how I'm building it. Cool. So let's go through this comment section and see if there's anything else that we should know about. This is funny, because I agree. These comments make the code harder to read. So most of the time you put the comments on the top. And the comments on the top are more helpful. So sorry, at the top of the code. So you put the comments on the top of the code, then you could see it more help. It's easier to read. And then there's like multiple lines, which is the one that I tried out. For the multiple line ones, you could have one that is just the beginning and the end. And then you could have the ones that has like the stars on every line, which my editor already does for me. Okay, so you cannot really nest comments, which I'm not sure why you want to do that. Cool. So I'm gonna skip the parts about like good commenting, because for now, like I don't think we need that yet. Okay, so yeah, multiple line commenting, and then let's go into variables. And then here, I'm gonna change the name to this file. For this directory, I'm gonna call it. I'm just gonna call it day one. This is a one of learning C++. Okay, so here we are gonna be layering about variables. Okay. So for variables, Okay, so it's pretty much just explaining like how variables are stored. So most variables are stored in memory. Sorry, all variables are stored in memory. And let's see. Okay, so you're not able to access memory directly. You have to use objects to be able to access the memory. And an object is a region of storage, usually memory, that has a value and other associated properties, which they will mention in a different order. When an object is defined, the compiler automatically determines where the object will be placed in memory. Okay, so it's pretty much just saying that when you declare, so let's just do, you might see me doing like some weird things with when I start. It's because like my brain takes a bit of, if I use a language for too long and I don't switch between the two languages, it just gets in a weird state where it just thinks I'm writing one language. So it feels like right now I'm writing Go, which is not the case. So you might see me try to write. So Go, the way you declare a function is like this. So you're gonna see that a bit when I start. Okay, so the way it works is that I am now telling the compiler that I am declaring a integer which is called x. Okay, and then the compiler is gonna allocate some. When it's building the binary, it's gonna say where to store that variable in memory. Okay, so we could try that and see if it builds. Okay, so the first thing is that I noticed is, so it wouldn't let me compile it. If I was using Go, it wouldn't let me compile it. So I'm gonna make a note for myself. So it wouldn't let me compile it because there will be a this variable is not being used. Okay, so that's one of the things that I will have to be careful with. In Go, when I declare a variable. Yeah, that is also very true. Yes, that is also true. Thank you for pointing that out. Return is not really needed. Okay. That is true. So I wonder what is returning. Okay, so I built it, right? And then if I do, there's nothing. Okay, so, and then what is the x equal? Okay, so it defaults to 0. So, okay, yeah. That is interesting. Cool. So, two things. I'm not using x, and if I don't have return either. So that is interesting. Okay, so the next thing I want to check is what is the default state of x, right? So I haven't assigned a value to x, so I want to see what a default value is. Occasionally in languages like Go, you automatically get there is something called 0 values, that every time you define a structure or value, it automatically has a value attached to it. So let's see what C++ gives you. Okay, so the default one is 0, which is good. Okay. Cool. Yeah, so there will be a lot of that, of me going back and forth between the two languages, because I'm using Go as a foundation to learn. So the way that I learn new languages is by not like directly comparing it, but like doing referring bit of different features and pieces of the language itself. So I'm glad that you joined that. Okay, so yeah, so in Go, structures, if it's a pointer, is a and you don't have any, is an empty structure, is a nil, it has a nil value to it. If it's like an integer or float, it has a zero state attachment. Okay, so there is no default. Oh, so it's supposed to be undefined. How do I? Okay, so that will be like one cool thing. Maybe, yeah, I'm gonna change this. So thank you for that. There is no default values there, but there is undefined. Okay, cool. Thank you. Okay, cool. So it was pretty much, I guess it's just like a since I'm passing x to it. So yeah, so I guess it's only for like integers. Okay, so let's move on. Okay, so this is a type. So we're saying that x is gonna be an int. So we are using that here too. So I'm guessing here that the way it works is that, well, not guessing, assuming that this is a function. So we're declaring a function and we have to give it what it's going to be returning. So in this case, we're saying main is always going to return an integer. So we have type check there. Cool. Okay, that makes sense. All right, so we have, let's see. So yeah, so we have data types. So an int cannot have fractions. So you cannot have decimals attached, right? But a double can. So that's pretty standard. So I'm learning C++. So I created a libs parser a while back, well, 3 years ago from this. So I created this 3 years ago, and the reason I'm learning it first is I enjoy learning new things. So C++ was part of the list of languages that I want to learn. So it's the list go like the top are the top two is learning C++ and then learning Swift. Just because I think it's kind of cool. I wanted to learn Objective C, but it just looks very scary. So right now the top are C++ and Swift. So I'm learning I'm learning C++ to be able to take this program that I wrote in Go. It's a libs parser. So the way it works is that you could do like, it's just a language itself. So you could do like declare functions, you could print, you could create lists, you could do multiple things with it. The goal that I'm trying to do is, what I'm trying to learn C++ for is so I could take this and turn it into a C++ program, just to learn the basics out of it. And then from there, I might take it into like, oh, I want to try to make a game. So I might like pick up a framework, in a game engine. But for now, the goal is to be able to just rewrite this program into a C++ version of it. And maybe also use LLVM to create binaries out of it. So right now, the way it works is just like, it's an interpreter. So you, it just doesn't give you a binary, right? It's just a script. So it would be cool if I could just take, for example, I could write a simple program and then take that program and get a binary out of it. So I could write the program in libs and then get a binary that I could just run myself without having to like parse it again. So that would be the goal here. But we might be like months off from that because I don't know how to use so there is LLVM, which is like I believe it's like a backend for compilers. So we kind of most likely are gonna write our own compiler backed by LLVM at some point. But that's kind of why I'm learning it. Okay, yeah, so that's kind of why I'm looking into it. And like there have been some projects that a few friends of mine have been working on.
which I believe they're going to open source in a bit. But the goal will be also to be able to contribute to those projects too. But that's kind of even more far out. The project itself, I could look it up. I have it on my phone. Oh, I don't. Let me just put it up. So there's a project that is like a Kafka replacement that is reading in C++. And the goal is to be able to replace Kafka with a C++ version of it. It's supposed to be more efficient. So this is a company. So this is they have like a open source company, but they created this project called Red Panda, which is just like a version of Kafka that is reading in C++, and by version I mean like is reading in C++. Sorry, it uses the Kafka API, so you could just like use the same dependencies that you will use to connect to Kafka, and then it's supposed to be more efficient and some other stuff. But the goal is like being able to like contribute to this project. It's still far out. I think they haven't open sourced it yet, but that will be like the goal to be able to do it. I think you could try it out, but I might try it out during one of like SRE DevOps ish streams on Thursdays. But for now, like that's kind of the long vision is first learn the language, then so learn the language as much as you can, then try to write our own Lisp interpreter, then probably try to turn that into LLVM compiler backed, like create our own binaries, and then most like 6 months out, or maybe less, when Red Panda gets open source, I could contribute to it. And like the thing about Red Panda is like it's a distributed system, so I really enjoy working with distributed systems. So it would be cool to be able to contribute back to it. And it will be funnier, like better if it was reading Go, but it's mostly reading in C++ just for the efficiency. So that is kind of the goal there. Okay, cool. So we are gonna go back to learning about types. Okay, so the types that we have are, okay, so it's pretty much most of the basics. So you could initialize multiple variables. You could do one lines as well, which is cool because you could do the same thing in Go. So yeah, so you defined it. Oh, I see. So you cannot. So in Go, you could do something like bar. So you could do something like this, and then define all the variables in there. So I guess you cannot really do that there. Yeah, I see. You don't need it because you could do just, and yeah, so you don't need it. Okay. Yeah, it wouldn't let me compile it if I do like a combination of them. So just a new line for it. Okay, cool. Okay, then assignments are just pretty much the same. So you can do x equals 3, and that should do it. And because I have SAE, and yeah, so cool. That is very cool. What if I try doing this? So this shouldn't compile. No, it did. Oh, we did truncate it. No, that's interesting. Okay, so that is weird. So I will have to figure out why that worked. Okay. Cool. So we are assigning 5 to width and 7 to width. So the last variable will be 7. I see. So we could initialize it. There are 3 ways to
initialize a variable. So we could use equal sign. Then we could use parentheses. So we could do with 5. So here we could do S5. Okay, so I'm just chaining all the commands so I don't have to. Oh, I can't chain it. Okay, so. Wait, what the difference is? Okay, so that's working. I'm not sure why did it print 8. So. Okay, so that is one way, and the other way is using brace. And you could use brace as well for with the equal sign. So which is the direct format? Okay, so the direct one is using parentheses. Okay, so if we do a empty bracket, so empty brace, we will get 1 with 0. Well, that is interesting. So if we do, okay, so that one works, but sorry, that one doesn't work, but this one works. This one works. Oh, hey, SSP, how's it going? Here's. Thank you for stopping by. Okay. So if you compile this. Oh, wait. Why did the other one work? Oh, it's because I have 0. Okay, so since I have 0, it's not worried that I'm like the compiler is smart enough to know like, oh hey, it's like you have a 0, it's not really a double or a float. We're just gonna drop the 0 because that doesn't mean anything, so you don't have to worry about it. But if I do like 5, it tells me like, hey, you're doing something wrong. Okay. Okay, cool. That totally makes sense. So at the end with these notes, I'm just gonna take all these notes and put them into a document for myself. Maybe like a README file or something, for like future references. Okay, cool. So that makes sense. So because I had 0, so I have 3.0, so the compiler was like, nah, you don't need that 0, so I could just drop it, and then I could just compile successfully. So it was more enough to just get rid of the 0, because you're not losing any value. But here it's like, hey, you're gonna lose that 5, so I cannot really do anything here. You should fix that. So okay, and this is how the error looked like. So it gave me a very helpful error. And then you could like turn it off. We shouldn't. Okay, so cool. There is errors there. So the suggestion is, so I guess I should go to the best practices. Okay, so as I go through these documents, I will make sure to just read the best practices if there's any there. Okay,
So we are gonna use the direct initialization first. Sorry, that's a really hard word. There's so many vowels there. Okay, so if we are gonna define a value, initialize a value, we are gonna use the parents. Okay, and we're not gonna use equal signs. Cool. And if we, I guess you could also use parentheses for initializing an empty one too. So let's see if this works. No, that didn't work. So I guess empty ones, if you want to initialize a empty value, you have to use braces. Okay, cool. That's good to know. So let's write that down. I'm just gonna copy. Okay. Okay. Cool. Okay. The best practice is also to initialize variables when you create them. So we shouldn't do something like. So we know x is gonna be 5. We shouldn't do this. We should do 5. Okay. Cool. So you could also initialize when you have multiple variables in the same line of the same type. So you could do something like this. Okay, also makes sense. So we are going to be sticking to the second case. We only going to use brace for initializing empty values. Okay, yeah. Okay, that makes sense. So if you cannot really say like, oh, all of these values are going to be equal to 5, you have to initialize each one of them individually to be able to accomplish that. Yeah, so that's kind of how the parentheses are going to be helpful. Because if you use parentheses or brace, it just shows you like, hey, this is only going to initialize V and not D. Sorry, and not A. Okay, cool. So that is chapter like this. Okay, so to summarize, what we have is we have 3 ways. Let's just say create variable. And then the first one is just int x equals 5 and x 5 and then int x equals 5. And we want to stick with this one. Okay, so we have, and I have a comment about empty values here. Okay, cool. So that's variables. I didn't know, so I knew from C that we could define variables by just the equal sign. I didn't know I had 2 other ways to do it. So kind of prefer the parentheses one because it looks more direct. And then I'm not sure what the reason is, like they're not choosing to use the braces as the main one. But either one looks, I'm into either one, so that's very cool. Okay, and it's less writing that I have to do. So I only need, if I count the spaces, I only need 1, 2, 3 here, and I need there is no space, so I need 1, then the value, and then 1, so 2. So that's saving me 1 character. Okay, we were gonna do this one here. Okay, so we are doing IO. So IO is from what we learned in our hello sample. iostream is mostly used for writing to the console. So you could write to the console and you could read from the console. So that's what we're going to be learning next. Okay. So again, we are going to include the standard iostream library from the standard library. So again, we learned this from the hello example. This is kind of how you import libraries into your code. And one thing that we didn't learn here is what this stands for. Like, what is this doing? So we might need to go find that out. I can assume I'm assuming that it stands for, so I'm making an assumption that I'm assuming that it's used for scoping. So maybe somehow the standard library, so this just stands for standard library, which is what in the commands that we're running, it's pretty much the same. So I'm assuming that the assumption that I'm making is that this has to do with some kind of scoping, right? It's like there might be like so Java has namespaces. So the way to think about it, maybe this is like a namespace, and the columns and cells are used to access values or functions or structures, I guess, inside of that namespace. So if we could just do that. Okay, so I put namespace isolation. So what that means is mostly like when you use namespaces, you're able to like, where things are coming from, kind of, right? Instead of like, one of the biggest problems that I had with PHP was like, PHP has namespaces too, but before it did, you didn't know where the functions were coming from, or like where was this one function being imported, and like what it was really hard to find like where things were being defined or where they were being used. Okay, so cool. So we learned that count. I think I'm gonna call it count. Say count, but without the end. So I can't really figure out how to pronounce it. So I'm gonna go with just this thing here. So this, it might give us what it means. Oh, so it's called variables. Okay, so this variable here is it's like a string, so you could write to it, and when you write to it, it's able to print whatever you write to it to the user's console. And the way that you pass data to it, or you send data to it, is by using an operator, and in this case the operator is 2 arrows pointing to it. Oh, it's called the insertion operator. So we're using the insertion operator here to insert data into our variable. Okay, so let's see. iostream library contains a few predefined variables for us to use. One of them is useful is st ::cout, which allows to send data to the console to be printed as text. Count stands for character. Output as reminder. Here's the hello world program. Yep. So this is how our hello program looked like. Okay, so it looks like you could print a lot of things, right? That's interesting because I wonder how that one works. I wonder if it's like a... Okay, so we probably will need to figure out how you could pass a variable that is a... Oh, that's easy. It's just probably using overloading. Okay, so if we do that, and we do count, and we pass... So... Oh, I don't know how to do strings, so for now... Oh, that's right. So I believe there is a type char, because since C there is one. So let's try that. And we could do hello. Oh. Okay, and then here we use. And we're gonna return 0. And because I'm not passing like the output, it's always gonna be A. So we're gonna be called A. So okay, so that wouldn't work because okay, so I have to define it. So we will have to learn. I don't think we should learn that yet. I'm just gonna pass a 4 for it. The reason why is like this gets into like arrays, and we haven't gotten into how to manage arrays and things like that. Okay, so we could pass a 4, we could pass this, so we could pass an integer and a string to it. We could define a variable. This is pretty cool. So we do end, and we use... Wait, here's something interesting. If we're supposed to use... Oh, maybe... So here's the struggle. Is they are using braces, so I guess I'm wrong. I guess when they said in the tutorial in the last chapter that the direct way is better, they meant that you could use parentheses or the braces. So maybe I should change that and say so we could use either one. So I'm guessing that both are direct. So this is kind of where idiomatic becoming like doing idiomatic code becomes a struggle. It's like now I am struggling between which one I should be using, right? If I didn't learn about like, oh, you should use this one or that one, I would probably have stuck with the equal sign. But now it's like, wait, which one do I use? Do I use that one, or do I use parentheses, or do I use braces? Oh, I don't know why that trigger. So did someone subscribe? Oh yeah, hey Will. Thank you for resolving. So the alert that you just saw coming down was Will resolving. Oh, I don't see it. Oh, I see. So I don't see. So I have the creators, the stream dashboard open, and unless you share it specifically, I won't see it. So I will only see the alert. So thank you again. Welcome back. Thank you for resolving. Okay, so the struggle here is now, which one should I use? I'm probably which one is closer? Okay, so I use a 60% keyboard. So that means that if I want to get to a number, it's very I don't have a my keyboard is very short. So this is a keyboard that I use. Oops, sorry. I just hit it. So this is a keyword that I use. So it's like very tiny. Hey, well, how's it going? So I am gonna pick brace because my keyboard is very tiny and brace are very close to their. Yeah. Okay. So we are gonna go with this one. Okay. Cool. So now that we got that out of the way, we are gonna go back here. Okay. So we are changing this to brace. No, not P. Okay, so cool. Okay, so that is that. Let's go back here. Okay, so it prints 5 because we're defining 5 and then it's printing it. And here we are just saying take the value of X and send it to the user's console. So it's gonna print 5. Because we put 5 here as a variable for it. Okay, so now what is next? To print more than one thing on the same line, the insertion operator can be used multiple times in a single statement to concatenate, link together multiple pieces of output, for example. Oh, that's very cool. So I could do something like 5 people. So we have 5 people. Okay. Cool. So okay, so it doesn't add spaces. So it just like okay. So if we do this, then we should have the space. So you have to handle your own spaces, which is what it is expected. Yeah, which is what they're showing here. Cool, so you could put it anywhere. And then what does and do? Okay. Okay, cool. So if we do multiple lines, so what it's saying is that we could do, if we do something like and we do people, right? It will be just really one line. Oh, wait. Oh, that's gonna happen a lot. It looks for me. It's like it looks like count. Okay, so it prints this on the same line. So I am assuming that if I do that there, so it's like a oh, okay. So here's the thing. So if I do something like, I wonder if this is supported. Okay, and then we do that. Okay, that puts it in a new line. So that's very cool. So I am assuming N L or L M it just gonna add a new line when I use it. So if I do something like that, I think yeah, it might be scope. So is this scope? It is. Okay, so think that might be a constant value. Yeah, it is. Okay, so this here is a constant value that just adds a new line. So that's very cool. So we are adding a new line to our program. So we can do something like that for a new line. Okay. Okay, so we add a new line by just using this value here. Okay, so they are saying when we use NL and variable, is gonna just cause the cursor. So this thing here, oops, this thing here well, that thing there, to move one line. Yeah, so it's gonna do a new line. So this is what I was trying now. So we're using \n, which is used to create new lines. I guess they're gonna describe the difference. Okay, so if we use the value itself to create new lines, it could be inefficient. Oh, I see. So if we use, I guess this is doing more. It's not. I guess maybe it's a function. I'm not sure what to call it because it's doing a lot of things, right? So what this is in here, if I use this value, right? If I use I'm not sure what to call it. If I use n, right? If I use n and I pass it to our insertion operator, it's gonna do two things. It's gonna add a new line, but it also flushes the data. So what that means is, instead of printing everything at once, like just printing 5 people all at once, it's gonna print 5, add a new line. Sorry, it's gonna print 5 and a new line, and then it's gonna move on. It's gonna flush it to the console, and then print the next line will print people. But if we don't use the n variable, then at a point it's just gonna print 5 people new line. Sorry, 5 new line people. So the way it will work is like instead of printing 1, so 5 new line and then people, it's gonna print 5 new line people. So that's the kind of difference there, and that is why it's inefficient, because it's easier to just flush everything together than just flushing the first part and then flushing the second part. Okay, so in most cases, using the new line characters is better because it's more efficient. But it doesn't flush. Yeah, it doesn't do like multiple flushes. Like the flushes, it will be, if we were implementing like a ACP server, then it will be useful because you have to flush. If you're doing like a server send event server, you have to flush every time that new data you want to send new data. But in this case, like we don't need to flush to the stream because like we expect everything to be there. Okay, cool. So we learned how to use. So I knew how to use this one already. This is new. So we're using single quotes here. So we're doing something like the way I had it. So the way I had it was something like this, which is just saying that this is a string. But the way that they have it is single quotes. So single quotes here, which does the same thing. So I am assuming here, since I'm not sure what single quotes do yet, but because in C and in Go, double quotes, single quotes are okay. So they're single char types. So what that means that here, this is only one character that you're using. So it's just gonna be one. Yeah, it's just type 1. So if I do something like this, that wouldn't work, right? Yeah, it will complain because I'm using too many characters in there. But if I do double quotes, that works. Okay. So with single quotes, you can only define one character of a string. With double quotes, you could declare multiple characters. So like we're doing here. Okay. And then Cool. So we learn new lines, and we know for best practices, we know that \n is way better than using the n line variable. There's a warning using a backslash. Yeah, so we don't use forward slashes here. Okay, and the next one we're gonna learn is SN, which we haven't used before. Okay, so we have that one there, and now we're learning a new one, which is called. Oh, we are also learning a new operator. So we're learning the extraction operator, which is the arrows are pointing in a different direction than the instruction operator. Okay, so the way it works, let's see. So the SN is another predefined variable that is defined in the stream in the iostream library. So first one that we learned prints data to the console using the insert operator. SN stands for character input, reads inputs from the keyboard using the subtraction operator. Okay. Cool. So it looks something like this. Okay. So here we are going to use our extractor operator, which we are just going to assign it to X. And we could just print the same thing back. Need a new line. Still keep it in one line. Okay. And now we should also print the message. So let's add a new line here. Okay, so we added a new line, and then here we could just. So the way it works is that we could ask a question, and then we could print it back. Okay, so we are gonna ask a question. Enter a number. New line. Okay. Then, so the way it's going to work is that new operator that we just learned. So first we're going to ask the user enter a number. Then we're going to use the new variable and operator that we learned. So we are using SN and the new operator, the new extractor operator to extract whatever the user enter into X. And then from X, we are going to print that back to the user. So whatever they enter. So let's see how that works. Okay, so enter a number, we say 10, and then we get 10 people back. Oh, that's very cool. Okay. So let's go to the best practices. Okay, there's a debate over whether it's necessary to initialize a variable immediately before you give it a user provided value by another source. Since the user provided value will just be overriding the initial value in line with our previous recommendation, the variable should always be initialized. Best practices is to initialize the variable first. Okay, so we are already doing that. Okay, we are already doing that. So we're already initializing it here with 5. So we don't have to worry about it, but for future references, X should always. Oh, nice. Yeah, I do have a standing desk. So I've been standing this whole time. Oh, take a seat. Okay, I'm gonna be taking a seat. So I have those rewards standing or taking a seat. So SSB just took a seat. So now I'm sitting. Okay. Okay, cool. So yeah, so I was standing this, and then some of the rewards for the stream is standing or taking a seat. All right, so we learn. So we have two new variables that we can use to send and receive information from a user. We have sin to get things out. Oh, and I can just call this one, sorry, cn and cout. Yeah, that's way better. One is to get input from the data, and then the other ones is to get so you get input and output of from the user. So you can send information and receive information. And then we learn a new operator, which is a subtraction operator, which takes data out of a stream. So pretty much this, which is very cool. Okay, the next one we're gonna learn is initializing variables and undefined behavior, which is kind of what we got into before, where I was talking about how Go has like it initializes all the variables automatically, so it zeroes them out. So you have like empty structs, which are nil if they're a pointer, and so on. Okay. Like some programming languages, C and C++ do not initialize most variables to a given value. Just like 0 automatically. So that's kind of what was pointed before. Oh, cool. Thank you for the 170. Cheers, Will. So I discovered how to get cheer points by watching ads. Thank you so much for those beats. Cool. Okay, so I'm gonna learn a bit more about this, and then I'm gonna take a 5-minute break, and then I'm gonna come back, and we are gonna do like, I want to do this the first chapter and then the second chapter, and then take a break, and maybe next Saturday I can come back and do chapter 3 and 4. Okay. There are 18 chapters. Cool. So like it was mentioned before by Stepan, there are no C++ doesn't automatically initializes some variables, which is here. Okay, so that makes sense. Oh, that is kind of dangerous. Yeah, it's so good. Like standing desk is really good. So I usually sit. Well, for the stream I mostly stand, but for like during the regular day I sit and stand. Like I stand for like 40 minutes, and it's like super nice. Thank you for the hydration, Will. Cool. So, okay. So, that's kind of interesting and dangerous here is that undefined values have garbage in them. That is kind of dangerous because we might read memory that we shouldn't be reading from. Well, using values that we shouldn't be using. Okay, so we should write that down. So, undefined. Undefined variables are uninitialized. So variables that have not been Okay. I think that's good. So what that means is like if I have a if I do something like int x and then sorry if I do int x and then I try to use that for something else, there might be something else in that memory that might not be the value that I'm expecting. So since I'm not initializing it by doing the braces, the memory there could just be anything. Anything that is in that address space, which could be interesting. Cool. Oh, one cool thing that I noticed, Will, when you send the bits, it showed up in the chat, and it said how many you did. So maybe we could ask support for that in the overlay too. That was kind of cool. Okay. Many okay, initializing the object is given a known value at the point of initializing. The object is given, so assignment, a object is given a known value beyond the point of definition. On initializing, the object has not been given a known value yet. Okay, cool, that makes sense. So here x is only initialized because we haven't given a value. And then we're gonna print something. We are gonna then send x to the console. We know what we'll get because x is uninitialized. Oh, okay. Yeah. So because we have not initialized it, the value of x is who knows, because we might get 0, which we've been getting, because I guess there is the compiler is doing something in the background. But the idea behind this is that x could be anything in this case. So it could be a number between negative. So yeah, it could be anything. So it could be like the biggest integer to the smallest integer that we could have. Okay. Some compilers such as Visual Studio will initialize the content of the memory to some present value when using a debug build configuration. This will not happen when using release build configuration. Therefore, you want to run the debug program itself. Make sure you use a release build. Oh, so the compiler itself tries to just... So Visual Studio does some stuff when you build a when you build it in a debug version. Okay, so this is what I wanted. So I wanted a way for us to so let's try this. So I need a way for us to get an error if we try to use a value that has not been initialized. So I might have to add a flag somewhere to be able to handle that. Oh, okay. So I miss a semicolon. Okay, so it's still compiled, so I don't get the error. So I need to figure out how to get Clang. What was the error that they got?
want. Yeah, I want to get that error. Yeah, so I want to be able to get an error if I'm using a value that is not. I'm not sure what flag to use. So I don't want to do automatically. I don't want to initialize it either. So maybe I might have to use like this flag here. So we will learn what that does in a bit. But the goal is to get an error. No, wait, why am I still initializing? I'm not. So we should be getting an error. Great, so we might have to depend on a different tool to be able to do that then. Because it's not giving me an error. Wait, am I? No. Okay, so it's not going to give me an error. Wait, it should be giving me an error, so I have to research that. Okay. Cool. Okay, so we didn't get the error, so I made a note to just research how to get that error. Because it would be very helpful for us to know if we're using something that is not initialized. Okay, so for now, undefined behaviors, or just the behaviors undefined. Using values for an uninitialized variable is our first sample. Is undefined behaviors is the result, executing code. Oh, it's not well defined, so we really don't know what is it undefined behavior for anything and for most things. Okay, so any of these things could happen if you use a undefined, if you don't initialize your value. So your program could produce different results every time it runs, because since it's allocating different memory in different places and different the memory itself could be used for something else, and that something else could just be doing some weird stuff. So that means that you could the first time you run it, you could get a 1. The second time you run it, you could get 100. The third time you run it, you could get like 500. Okay. Your program consistently produces the same incorrect result. So if you're expecting something to be there, like 0, you might get something else.
Your program seems like it's working but produces incorrect results later in the program. Yep. So because the memory itself could just be something else. Your program crashes either immediately or later, or your program works on some compilers but not in others. Your program works until you change some other slightly unrelated code. Yeah, because that means the location is gonna change somewhere else. Okay, so this is bad. So we should always initialize our values when we first define them. And we could just initialize them with 0. Well, sorry, not with 0. With just braces, empty braces, because if we don't know the value of our. Yeah, so we should try to avoid undefined as much as we can. Okay, so here there's not nothing much, just an example. And I'm gonna say only initialize variables can be anything, always make sure to initialize okay, or bad things will happen. Cool. So yeah, that's kind of interesting, because it sounds really bad. You might be expecting something to be there, but it's not there. So you could pretty much just get anything, like any trash. Okay, so I'm gonna take a bit of a break. Thank you so much for watching. If you are enjoying this content and you're looking forward to learning more about C++ in the next couple of weeks or months, while I learn it myself, don't forget to press the follow button, or support the channel by subscribing. Cool. So one thing I thought during the break, maybe there's a way to force the compiler that we're using to force the compiler to initialize all our variables. So if we do something like this here, we could force the compiler to start to initialize it for us. That might be a way to get around it. But that means that it's compiler based, and like if we change between compilers, so if we go from Clang to C to GC, it might not work. We might have to remember to pass a flag. Okay, so compiler to initialize. We should still be very careful to do that, because if we don't, just continue initializing ourselves, we should be careful. Okay, we should still do it, just because like if we change compilers, things will get weird. Okay. So if we change the compilers, we have to figure out like which like we will have to go and figure out how to turn it back on. Okay. So we're going to learn about keywords and name identifiers. Okay. So keywords are specific words that you cannot use because the language itself has make it that they're reserved for itself, right? So for example, when we use int, the one of the big ones, int, I don't think, it wouldn't let me call something in it. So something like this wouldn't compile. Because int is a reserved word, it's a keyword
that the language itself uses for types. So that means like there's different things. Can I call it case? There's some that you can use. Yeah, so right, for example, you can use case as a variable name. Okay, so these keywords cannot be used again because the language itself is using it. So for now, I think I'm just gonna breeze through this because I want to. We are gonna learn some of these keywords as we go forward in the language itself. Oh, it also. Oh, okay. So some of the things we might need to stick with, like variable names, like the best practices for it. We are going to use low cases for values, and we shouldn't start with a capital letter either. So we shouldn't do any of this. Okay, so that's cool. And then function names. So a function name, you could use snake case. So you could use snake case for you're gonna use snake case for variable names and function names. So that means that we are gonna use underscore for spaces. So for example, if you're writing some Go, the first example, so something like this. In Go, it will be my function name. In this case, we are going to try to stick to camel case. Sorry, not camel case, snake case. So this is called camel case. This is called snake case. So camel case is not used here. Wait, it is. So how do I decide between camel case? I guess I will probably stick with camel case so I don't have to struggle mentally. So since I'm starting this and it's my own code base and I'm not starting in a legacy code base, I'll probably just pick camel case because both is all that one, correct? Okay, so yeah, I'm gonna stick with camel case because I'm learning. Yeah. It's interesting that they call it snake case and camel case. So I'm gonna stick with camel case because that's kind of what we use it when writing Go. And this is a new code base, so I don't have to. There's no standards yet for it. So standard is we're gonna use camel case. So we're gonna use that one. So we're gonna use camel case for going forward. Even if the example has snake case, we're just gonna go with camel case. Okay, here. Okay, so we should always start our functions or variable names with lowercase. When you're writing Go, if the first character is uppercase for a variable or a function, it means that the function itself or the variable is a public variable or function, and it could be accessed from outside of the package. In C++, there's no concept of like uppercase and lowercase doesn't really mean much. But you should always start your values with lowercase, so it looks like. Yeah, so pretty much the best practice is just pretty much summarizes it, what I meant. When working in a system program, use the conversion of the program, even if they don't conform to modern best practices. Use modern best practices when you're writing new programs. Okay, so now the question is like, which is the best practice? So again, this book tries to show you best practices, like idiomatic at the same time, and not book, tutorial, which is kind of like the thing that I was trying to avoid because I think I spent so much time trying to figure out like, oh, should I use uppercase or lowercase? So for now, I'm gonna say that camel case is the way to go. Second, you should avoid naming your identifiers starting with a underscore, as names are typically reserved for OS, libraries, or compilers. Okay, so we shouldn't do something like my function name.
Okay, so we shouldn't do underscore. Cool. However, giving a trivial name or giving a trivial variable a overly complex name is independence overall understanding of what the program is doing almost as much as giving a widely used identifier an inadequate name. Therefore, a good rule of thumb is to make the length of the identifier proportional to how widely it is used. Oh, that's interesting. Clear, we're count. What does the C for count stand for? Okay. Oh, yeah. What does this stand for? So it's C count. So you have to just give it a full name. So don't use like short names for trivial. So if you're doing like customer count, you should use if instead of C count, you should do customer count to be more explicit. Same thing with I, which is for use for indices. So pretty much for trivial stuff, you're okay using further names. And count underscore. So don't do underscore. Okay. Same thing for the names. Give me a second. Okay. Cool. So for naming, we just want to avoid underscores, and we want to give the names more context. So when we name something, we should give it more context. We shouldn't just do C count, because what is C, like this says here. Okay. Finally, so if we want to, we could add a comment describing what the variable is being used for and give it more context as well. If the name of the variable doesn't make sense, it doesn't give enough context. Okay, cool. So that makes sense. I want to make sure how much left. Okay, I think I'm just gonna do a chapter. So I'm gonna just do chapter 1, then end the stream there, and then next time I will do chapter 2, because like it might be a lot to just do 2 chapters all at once. Okay, so we are gonna literals and operators. So we saw operators already. So we saw the insertion operator, and then we saw the extraction operator. So pretty much those 2 arrows. I forgot to create a new file, so I'm gonna create a new file for the past chapter. So naming, it was called keywords. Anything, I don't have anything. Okay, cool. So I'm gonna create a file per chapter. Sorry, for section of. Okay, and then, so yeah, so we learned about different operators that we could use. There were 2 main of them. So let's see. So they're explaining what literal are. So literals are like the values that you're trying to assign to a value. So hello world and 5 are literals. Because it's just a fixed, it's a fixed value, so that's kind of how they're going there. In math, a operation is a calculation involving 0 or more inputs. Okay, oops, sorry. I just stopped the microphone. Cool, so a operator could also be, so in our case, we are gonna probably learn about plus signs equals, like math, like being able to do math against our values. So the standard arithmetic operators from common usage used in math includes addition, subtraction, multiplication, and division. And then the equal sign. So okay, so I take it back. We knew before we got to here, we knew 3 operators. So we knew the equal sign, the subtraction operator, and the insertion operator. Okay, so it's so we have like some kind of different operators. So if you're doing if you're doing negative numbers, you have an operator there too. Binary operators, ternary operators. So like it's when we do wait, which one is it? Oh, so there's only one in, so we don't have an example of that one, but we have done at least the second one. We have done it a lot. We haven't done the first one yet, but we need to learn what the third one is. Okay, and this actor is pretty much done. So it's just doing math here. So we could just make a file that has all of them. So we are gonna include iostream, and then our main function, and then here we want to do we are just gonna print things out. Oh, we could do something like create a x and then initialize it. Then we could be like we could ask for an input from the user. So, and we could ask, please enter a number. So we're asking the user for a number. Then next thing we could do is wait for that number. So we could use our int. And then we have to use, so the first one is a insertion operator. The second one is a extraction operator. So here we are going to do assign it to x, which is a number. And then we could do, I think we might have some issues, but let's see. Here we could do, we're going to print out just x plus 1. So now we're sending something to our cout. Correct. So we're gonna send something to our cout, which is x plus 1, and then we're gonna get that back. And we can just take some of these things in here too, so we could make it more complex. So we're gonna do the same, and now we are gonna just continue using x. So x times 2 minus 1. Yeah, so we could try that out and see. And then we're gonna return 0. If this works. Did I miss? Oh, did I misspell it? I might have misspelled that one. So we could go back to our iostream and see how. Oh, it's not. I put a T and a T. It's just here. Okay, so we could try this out and see how it looks. Nope, still doing it. Yeah, there was a lot. But that is, for some reason, it looks like count to me. Okay, so let's see what happens here. Wait, why didn't they ask me?
Something might not be right. So it should ask me to print a number. Oh, it's because I'm passing an analyze flag. So I guess that if I pass the analyze flag to it, it's just not gonna compile it at all. Okay, there we go. So I'm gonna enter 5. So, oh, it didn't. Oh, here's the thing. I didn't add a new line, so I should add a new line. So I should do add a new line. So just printing everything in one line. Okay. Cool. So 11 and then 19. Cool. So that's kind of, it's interesting. So I wonder what the third operators are. Okay, so we could do math and we learn a bit more about our, well, we kind of review back these kind of the 2 operators that we knew already. Okay, so we have expressions now, which is, so it's when you combine multiple like multiple operations together. Okay, cool. So key insight. Okay, so most of the time, if you do this, the compiler itself will just convert it back. It will do some magic in the background, and it will just be 5, and it wouldn't do the math again. So that's kind of cool. Okay, cool. And then the last part, which is, okay, so we are going to learn a bit about best practices. I think this is the last one. Yeah, because we're going to do the summary, and then we are not going to do the quiz. Okay, so some best practices. New programmers often try to write an entire program all at once and then get overwhelmed when it produces an error. And better strategy is to add one piece at a time, making sure it compiles and tests. Then, when you're sure it works, you move on to the next part. Yes, this is 100%. So sometimes I write a massive amount of code, then I run it, and then there's like this humongous error, and I don't know why it's happening, because I ended up writing like 100 lines of code and I have no idea where it's happening. But what should usually happen is I write one line, like 5 or 10 lines, then I run it, make sure it works correctly, then I add more, make sure I write it correctly. So good point. Okay, so the end is we want to write a program that takes a number. Okay, so I'm gonna call this final. So final or summary. So the summary will be, so we're going to be implementing the same program that they're doing in the tutorial. Cool. So let's see what we need to do. Okay, so we need to do the first program we're going to create, that it asks the user for an input, it waits for them to put an input, then tells them what 2 times that number is. The program should produce the following output. Okay, so if the first we should do, and so we need to declare the value that's going to be holding it. So it's going to be, we're going to initialize it with 0. Sorry, we're going to just initialize it, so we make sure that we don't get any garbage. Okay, and then we have to return 0. So the first thing we need to do is ask the user to enter a number. So we learned that if we use the standard library cout, we could then ask for a number, enter a number. Okay, so we're gonna ask for them to enter a number. Oh, I forgot. Okay, so we are asking for enter a number. Cool. And then we're now waiting. So we learned that this is a insert operator, and then now we have to wait. So to wait, we learned that we could use end, and we could use a extraction operator. So we can extract the value that the user enters here. Okay, and we're not going to add a new line because you see how it looks. Okay, so then we run it again. Okay, so it's asking us to enter number. I'm gonna enter 4, but I enter here, and we see a 4. Okay, then here we have to double it. So the way it will look like is we're gonna use cout, and we're gonna use the new operator that we learned. We learned that we could use addition, or multiplication, so we could do ×2, and we could just do something like what's the output, double number is. Okay, and I forgot the insert operator. Okay, so that is kind of how it will look like. So if we enter 4, we should get 8. Okay, cool. And the tutorial, I'm guessing it just goes through like different things you should add, which we just went through. I'm not sure. I think I don't have to put the 0 there, but for now. Okay, so here they're asking for a number. The only difference here that I didn't do was I declare it on top, but I guess it's easier to just declare it where you need it, right? Okay, so we should do it there. Here, make a note. Okay. Cool. Okay, so they got an error, but we didn't. Why is that? Okay, let's see. We ran into a compiler error first. The program. Oh, I think maybe they have a typo somewhere. I'm not sure where the typo is. Let's see. Oh, line 8. Oh, okay. So the error that they made, which is that they're using a insert operator for a stream that is only you could only read from. So this is you could write to this stream, you could only read from the stream. So the compiler is saying, hey, you're trying to write to a read stream. So it doesn't really know how to use that operator. Yeah, so that's kind of what's happening there. Cool, and then they fixed it. That's very cool. Okay. Not good solution. So once we finish the last step, our program will compile and run successfully. There are at least 3 ways we could go about this. Let's go from the worst. Okay, so the worst one is doubling the number, and then I guess that's what's happening. The mostly good solution is I'm guessing that this is what they mentioned why is this bad one. So before the assignment statement, num contains the user input. After the assignment, it contains a different value that is confusing. Okay, so the reason why this one is bad is because we're reassigning back to num, so we are overriding that. So most of the time, you shouldn't try to reuse the values unless you're doing like a loop that is like looping through a set of values. You shouldn't go back and like try to update it. So that's kind of why it's happening here. Cool. And then the mostly good solution is not reusing num. It's creating a new one, which is just called double num. The first thing I will notice here is that it's just like reusing it, which you're using a bit more memory, which doesn't really matter, but you shouldn't really need that one. Define a new variable, and okay, this solution is pretty straightforward to read and understand, and it resolves both of the problems encountered in this worst solution. The primary downside here is we are defining a new variable which adds complexity to this. New variable which adds complexity to this. To store a new value we only use once, we could do better. So I guess because we're not using it again. Okay. And then there is the preferred solution, which doesn't reuse number. It doesn't declare a new value. Which I think this is what we have. So we have the preferred solution. So the preferred solution is int number. So we're initializing the number. The thing that I'm still confused a bit is like, do I need 0 there? So I'm gonna make a note saying, do we need 0? And I will find the answer later. This is the first solution of the bunch. When cout executes the expression, number times 2 will be evaluated, and the result will be double num value. The value will get printed, the value in num itself will not be iterated, so we can use it again later if we wish. Cool. So we could triple it too. 1 to 2. Cool. So the way that this looks like is like we want to make sure that we don't want to override the input of the user. So if we have a value, we should just keep it as it is and not override it. If we think that we're going to reuse it, we shouldn't do any weird stuff with it. So especially here, so in the quiz side section of it, we want to triple the number. And if we override it the first time and then we try to triple it, it would not be right, because we will be tripling 8 instead of 4 with the first solution. Okay. Cool. So yeah, so the goal is not to learn the language like fully, it's just to learn parts of it. Yeah, so that's kind of what we're doing. Okay, summary. So what we did so far. So what we did for chapter 1. So we learned just how to write a hello world. We learned a cout, and we learned that there is a we have operator, and then we use the operator to to read or write data into a variable. Here we are writing to cout, and then cout is going to print that to the console. And so let's just see what else we have in here. Okay, and then we learn more about iostream, which is a standard library that comes with the language, which has we only have learned 2 of the variables inside of that library. So we learned cout and cn. Like I said before, cout just print things out,
to the user's console, and then cin takes an input from the user into the terminal. Input that the user added into a variable that we have defined ourselves. And we could use new line against it. And there is also here, forgot to add a note here for ourselves. So we didn't talk about Undefine. So adds a new line, but also flushes stream. Okay, so it's not ideal because of performance, because we are wasting, instead of printing everything at once, we are not. So okay, so there is that. Cool. And then we learn about some keywords, which I misspelled keywords. So let's. Okay, so we learn about keywords, and keywords themselves are just I didn't add much here, but so keywords can now be used as variable names, which just means that we cannot use something like, for example, we cannot use something like type. So in the case of int, we cannot use int, or in some cases we cannot use if. We cannot use if as a variable name, or we cannot use case as a variable name, because those are keywords. Keywords. And then we learn about operators. Oh, what is that? Oh, I know what the file is for. We don't need this. Then we learn about operators, which is just means that we have multiple kinds of operators. So equal sign is. Just because we don't have an example with equal sign, I just want to make sure that I remember. Okay, so we learned about multiple operators here. We learned that we have the insert operator, and then we have the extraction operator. We learned that we could use some of the math. So we could do subtraction, addition, division, and multiplication as operators as well. Cool. And then we use we also learn about I think I skipped some, but we also learn about variables, undefined behavior, which if we don't initialize a value, so if we just do line 11 like init x, we could just get garbage data in there. Depending on the compiler, depending on whatever is in memory, you might just get, instead of getting like a 0, you might get like a 100 or 200. So that's kind of interesting. You should always initialize your variables, which is what we got from here. One thing I need to look into is like if there's a way to do it through the compiler, or we just have to do it ourselves, which we've been doing already. We also learned just mostly about variables. So we learned how to initialize the two ways of initializing variables, which you could use the equal sign, you could use parentheses or brace. We are going to be using brace from now on. We learned a behavior that the compiler has, where if you define 3.0, the compiler will drop the 0 and it wouldn't complain, because we're trying to assign a double to a int. We haven't learned about doubles or floats yet, but a float and a double is just you could think of them as decimals. Okay, and if in our case, if we define 3.5, then the compiler will complain, saying like, hey, you're gonna drop the 5 of, you're gonna lose some precision. Cool. And I think that's pretty much it. Yeah, so copy assignments. So we learned about that.
We learned about that. Literal. Yeah, we learned so like hello world. It's a literal content. And then operations. So like math. The one that is missing is this one. Which one was that? So I'm gonna look it up right now. Okay, so it's just when you use. No, that looks very complicated. That's. Okay, so I guess it's a condition operator. So is if expression 1 is false, then it's gonna do this one is expression 2, 3. If it's true, it's gonna do 2. Okay, so it's okay, that makes sense. So it's true and false. That's why we haven't seen it yet. So that's how it will look like. Cool. I think that's pretty much it for chapter 1. So thank you so much for watching. I'm gonna end the stream here. And then the following one, we will look into like learning functions and making sure how things work. If you enjoy this content, please don't forget to press the follow button. We also have a YouTube channel, so don't forget to subscribe there. If you want to support the channel, don't forget to press subscribe here. Thank you so much for watching.